Okay, so today I will do Leetcode 146. This is the LRU cache. You can pause the video and find the link there. And yeah, this is a question, so you can skip forward a little bit. I have a whiteboard here. I'm going to be drawing on a little bit of motivation at the top. Sponsored by David Goggins. Not actually sponsored, but I do appreciate kind of his wisdom. So yeah, design and implement a data structure. I'm just reading the question again. And I have a cleared my answer. So we're trying to get this LRU cache. And what LRU cache is, LRU stands for least recently used cache. So essentially a cache has some sort of capacity. There we go. Cache has a capacity, and the capacity represents how many elements, objects, nodes it could hold. So our implementation, we're going to create this class here. So class, we should give us some space actually. So it's a class LRU cache. This is going to be in Python. Let's do a define init. That self is like this keyword in other languages like Java. Self, it's going to have a capacity, like I said before, and then let's say self.cap equals capacity. And then so our implementation is going to include a doobly linked list and a dictionary. So let's say self.d is going to be equal to our dictionary. And we're going to define our node class here. So it's a class d node, d for doobly. I'm writing it too big, I need some space. Class D node, say define, have to initialize certain stuff, and in our implementation we're going to use a key value pair, right? So this node, pretty much like any node in a linked list, it's going to have a value, right? It's going to have key and a value. The self.key is equal to key self.val is equal to val, and then in a doobly linked list it's going to look like this, right? So node's going to have a next pointer, and then node is also going to have a previous pointer, right? Something like that. So self.next, and then these should be initialized to none. Sorry for my messiness. So I'm going to delete this. Okay, so that's our node class, and we can actually just leave it like that. So key value, next pointer, and a previous pointer. So now within this LRU cache, we're going to define two helper functions. And I'm going to run out of space here, but I'll just see what I can do. And also, so when we initialize it, so our cache is going to look like this, right? And let's say we have capacity 2. This is the first object, second object, and then when we add a third one in, and then since we're using a doobly, we have something like that. So we have this new node that we want to put in here. So what do we need to do? So let's say we put 1 in first, and then 2, and then we're putting 3 in. 1 was the least recently used one, so we need to delete this and then update our LRU cache to have just 2 and 3. So this would look like 2, next pointer to 3, 3 the next pointer to that, right? And then this, like that. These pointing to none. So in order to do this, we need to keep track of our LRU cache using two different pointers. So self.head we're going to say is a node, a doubly linked node. Doubly linkless node is equal to D node, and then you need to initialize that, so we can let's just say 0, 0. It's kind of like a dummy head, dummy tail. So we need a tail as well, because we want to keep track of the head element, the ones closest to the head, and also the ones closest to the tail. So the ones closest to the head, like in the previous example, that 1, 2, and then I did the 3 here. This is going to be closer to the head. Head is just going to be 0, and then tail is also going to be here 0. So the ones closest to the head are going to be the least recently used objects or nodes. So yeah, so tail is also another D node. And then initialize those values to 0, 0. So now we haven't finished our initializations. So we just have 2 nodes right now, right? And then this is the head, and then this is the tail. They're both 0, 0. They don't point to anything. So what we need to do is to update our head to point to our tail, our head.next, and then prev is still default, head.next is still default. And then we need to update tail.prev to equal to head. So that's easy, right? We're just doing this arrow and then this arrow. So self.head.next, which is right now it should be none, is equal to self.tail. So we just did that. And then self.tail.prev is equal to self.head, right? So self.tail.prev is equal to self.head. Self.head.next is equal to tail. And we can get rid of this. So now we need to do our our focus here is to do a get and a put. So get retrieves a node from our LRU cache, and then puts a node onto our LRU cache. So we're going to define 2 helper functions first before we even get to get and put. And I've seen I got this idea from Leetcode. I didn't get this answer the first time, and I don't think most people will. So yeah, let's do our helper function. I'm just going to write them down here, but they're going to be methods from our LRU cache, so they would be within this function column, I guess you could call it. So yeah, first one, I'm going to sit on a chair. All right. So first one is going to be a remove. So you're removing a node. And then this is going to be assuming that you have a doubly linkless node. So for example, let's say you have this LRU cache set up right now. This points to that, this points to this, this points to this, this points to that. Right, so let's say 1, 2, 3. And then the node we're trying to remove is this one, 2. So how do we remove this node? So what we need to do is get this pointer from 1 to 2. That would be 1.next is pointing to 2. And we need to update this pointer, right? So we need to update that next pointer to skip 2 and then go to 3. And then we need to update the 3's pointer to go to 1, right? So we want something like that. That looks like we removed 2 completely. And then the garbage collector, essentially, I believe we'll get rid of that object, the node 2. Yeah, so this is assuming we have that node and we can update. And the garbage collector would get rid of that node. So what do we do here? So we need to get a pointer to this previous node, and then we can call this like a next node or something like that, or just P and N. I think we might need to save some space, so I'm going to call it that. So again there, so let's say P and then N is equal to node.prev. Again, that would be 1 in this case. And then n would be equal to node.next. Right? So we have prev and next. So now we need to set prev.next is equal to next, and next.prev is equal to prev. A little confusing, it sounds, but it makes sense. In my head, at least. Yeah, so, okay, I'm confused again. So let's see. We have P and N. So prev.next is equal to N. And then n.prev is equal to P, right? P.next is next. And then next.prev is P. Yep. My marker, fixing my marker. So this is one helper function that we need, and then the other one is going to be an add. So we'll go over that too. Sorry for the filming. I'm holding my camera with my left hand. So let's see if we have space here. I think we will. So let's see. And that's all we need for the remove function. So for the add function, and then we can just do something like that. For the add function, and then these also need a self in here. Sorry. Self, because that's within our LRU cache. And you need the self to access these attributes, variables. So yeah, define add, again, you're adding another node, kind of similar to our remove function. So here we need to add it to our dictionary. Right, so we have a node, we have another node, and like I mentioned before, the nodes closest to the tail are going to be our most recently used, and then the ones closest to our head are going to be our least recently used. So when we add, we want to add from the tail, right? So yeah, let's say this is our tail. Let's say we have 1, 2, and then that points to tail, this points to head. We want to add from our tail. So when we update it should be 2 and then 3 if our capacity was 2, right? If our capacity was 3, then it would be 1, 2, and then 1, 2, 3, like that, right? So yeah. So when we're adding from the tail, right? So let's say tail prev is equal to self.tail.prev, right? So let's get another example. This is the tail, which is 0. To that, and then this is 1 and 2. My arm is dying. Okay, and then we're adding 3 into here, right? So we're adding 3 into there, which means we need to update the pointers to look like this. It needs to be 1, 2. 2 should point to 3, point to 2, and then I'm running out of space. But then the 3 should point to the tail, and then the tail.prev should point to the 3, right? So right now we have tail.prev, or tail prev is equal to 2 here. So tail prev, right? So all we need to do is set tail prev.next is equal to the node that we're inserting, which would give us this. And then we need to set our node.prev is equal to tail prev, which would be this. And then self.tail.prev is equal to our node that we're inserting. So this would be there. And then node.next is equal to self.tail, like that. So that looks ugly, so I'll just do it again. So yeah, let's just say we have this node and then our tail, or our 2, and then 2 is pointing to our tail. Right, I just wrote what I have above, oops. Okay, and then we're inserting 3, which would mean we get rid of these 2 pointers. And then we would have a third node here, 2 would point to 3, 3 would point to 2, and 3 down next, self.tail, self.tail.prev is equal to 3. Right, and then we have a pointer to this already. Like I said, tail prev. If I'm going too slow, it's because it took me a long time to understand this. So hope I'm helping someone out. So yeah, this is tail prev. And then, like I said before, tail prev, underscore prev is equal to the node. And then node dot prev is equal to tail prev, and node dot next is equal to self dot tail, and then self dot tail dot prev is equal to node. Okay, so that's our node class. These functions methods are not a part of the node class. They are a part of the LRU cache class. This is the initialization for the LRU cache, and then these are the remaining methods, and then there are 2 more. So these are the remove methods, and I went over kind of what they do the illustration. I'm going to erase these right now so I can write the other remaining 2 methods, the get and the put. I'm also going to delete the node class because we know what that looks like. I don't want to keep saying delete, I mean erase. So yeah, and then I'm just going to write the other functions we wrote. So we wrote the add, and then we also wrote the remove. And then they each take in self and node. Right, and then blah, 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 whatever. Okay, so this is let's do the get first. Find get, self, we're getting by key. So first, when we're getting a node in our LRU cache, just the act of getting something actually updates our whatever item that was to be the most recently used item in the node. Okay, so let's say our function put is working. We see like put 1 put 2 and then get 1, and then put 3 and then let's say the capacity was a 2. So when we put 1 we have 1, and that's pointing to the tail, and then the previous is pointing to the head. And when we put 2 we're putting it from the right because it's, we want it to be our most recently used item, right? So we're doing that. And then when you get 1 is no longer the least recently used item that it is before we do the get. So now we need to update the 1 to be more recently used than the 2, right? So when we do the get here, the 2 is now our least recently used item, and then 1 is our most recently used item. And then when we put 3, since our capacity was 2, we would actually get rid of the 2 now. And then our least recently used after that put would be the 1 again. right? And then that's the tail and that's the head. I didn't actually write the notes, draw the notes, but they exist. With the 0, default 0 like we did here. So that's what we're doing with the get function first, and a little bit of rundown of the put as well, I guess. So when we need to check if what we're getting exists in our LRU cache, and the way we're doing that is through that dict that we did here, that we defined. So we need to check first if it exists in our dict. So and actually I just looked this up recently, and in Python 2, when you do something like this in self.d, it actually isn't in constant time. So you have to do it in Python 3 to have it in constant lookup when you do the syntax. When you do like in Python, you could do like something like that. That would be constant time, but I don't remember the exact explanation, but I'm pretty sure that's the case. So yeah, if key in self.d, and then that'll just iterate through the keys in the dictionary. Let's see. So we want to check if the key is in the dictionary, and what would that mean? If it's already there, then we want to remove it and then add it again, because when you add it again, it's now the most recently used, right? So let's say node is equal to self.d key, and then our value is going to be the node itself. So that's why we have it written like that. So let's say, and we have our remove and add functions that we wrote before, so we can just call these here. So let's say self.remove that node, and then self.add the node. And then we want to, I believe it says you should return the value of the node when you run the get. Let me see here. Get the value, otherwise return -1. So we want to return node.val. And then outside of the if statement, we can just return -1 if it doesn't exist in our dictionary. All right, back to the chair. So the last function that we're defining is our put function. Sorry again. Put self. And this is going to, so we're putting a node inside our LRU cache, right? And then our node we defined before to have both a key and a value. So when we're putting a node in there, we need both the key and the value. Okay? So let's see. Again, we need to check if it already exists in the dictionary. Because if the key exists, we need to take it out and then update it in case the value is different. But also, we need to move it from where it was to the most recently used, right? So let's do another check. So if key in, and we might run out of space, so we need to write small. If key in self.d, we need to remove it. Let's do self. I'm just gonna write on the same line. Sorry if that's hard to read. Self dot. It's dot underscore remove self dot d of key, because like I said, the value is a node. Key in self dot d self dot underscore remove, and then when we remove it from our dictionary, oh no, so when we remove it, we're removing it from our node, our linked list. So if key is in self.d, then we're removing it using our remove function. Yeah. And then regardless of whether we move it or not, we need to define a new node. So let's say node is equal to dnode of key and value. So now we have this new node, and then we are going to add it into our cache. Okay, let's see. I'm thinking here. So if key is in self.d, then we're removing it because we just saw it. And then after that, we're going to create a node with that key and value that we were just given. Yeah, and then we'll add it. So do self.add underscore add. And that add just takes in a node. So we'll add that node. And then now we're adding the node. And when we add the node, we also need to update our dictionary, right? So self.d key is equal to the node. And then now we need to check if our capacity has been reached. So we need to do if length of d is equal to self.cap. Then we need to remove from the head of our linked list, of our duplicate linked list, because like I said before, our head is our least recently used, right? So not equals equals. If length of d is equals 2, we can have 2, so no, greater, yeah. So if cap was 2, then if the length of the dictionary was 3, is only when we would remove, right? So let's say near head is equal to self.head.next, because self.head is a default list node. So near head is self.head.next, so we need to remove that. So all we need to do is we can call a remove function again. Remove near head. And then we also need to remove it, we need to delete it from our dictionary too. So in Python, you can just do that by writing del self.d of near head dot key, because we need the key to access our value, right? So we're deleting that there. And then once we've deleted that, let's see, what else we need to do? Set, and then let's finish invalidate. So we're deleting there, and I believe that's all we need to do. Yeah. So let me just double check what we're getting. We're checking if the key is in dictionary. If it is, we're getting the node, and we're removing it, and then we're adding it again. And then returning the value of it. Otherwise, returning -1. And the put, if it's in the dictionary, and then we're going to remove it, and then we're going to create a new node with that key value, and then we're going to add it into our linked list, and then also our dictionary. And then if the length of the dictionary is greater than the capacity, we want to remove the least recently used item from our LRU cache. Doing here, and then we also want to delete it from our dictionary as well. Yes, I believe that would work. Okay, thanks for watching.